All right, we're looking at the first lesson in geometry. And there are a couple of terms that we want to discuss today for sure. And then also we're going to look at some shapes. So some very important terms that we should look at first are points, lines, and planes. And then we're going to look at some shapes such as triangles, and then we're going to look at some less regular shapes. So we're going to look at angles, and then we're also going to look at rays and segments. So if we look at all that, I think we're doing pretty good. It's kind of a long lesson here, but I think it's worth it. So we're going to first go back and look at a gentleman named Alexander the Great today. And he does play a role here, strangely enough. Alexander the Great. And we're also going to look at Euclid. So these are the two people we're going to be looking at today, as well as some terms. So let's start off with Alexander the Great. So he did go around and conquer most of the known world, and while he did that, he would take over a major city within a country, and he'd usually rename it Alexandria. And so there were many cities and towns called Alexandria long ago. We're talking a couple thousand years ago. And one of those towns was in Egypt. And so you've probably heard of Alexandria of Egypt. And the reason that it does come up quite a bit is because it's a hub of knowledge. It became a hub of knowledge. He wanted to have the great library put there. So there was the great library of Alexandria of Egypt. And there that they took as much knowledge as they could, books, scrolls, parchments, all the writings they could find, and they put it there in this one place. And a gentleman named Euclid, who we don't have much, if any, real history of. There's a lot of historians that might even say that Euclid was more than one person, that it was a group of people that went to Alexandria of Egypt and decided to compile all the knowledge they could of geometry into one book. So they took all the parchments, all the scrolls, all the sheepskins that had been written on, and tried to compile it into one book. And that book was called the Book of Elements. And the Book of Elements was basically a geometry book, a textbook. It was basically a textbook of geometry. It taught you geometry. And one of the things that Euclid tried to do off the bat was define every term in geometry. He felt that it was very important that you would be able to define everything. And when he got down to some basic terms, he realized to define a point in space. So here we've got a point in space. To actually define that, you'd have to use the word point in the definition. And he said that was breaking the rules of what a definition is, which is that you don't use the term in its own definition. So points were not even definable. He said you cannot define a point. It's just not possible. So then he said, okay, well, how about lines? And he recognized that you could not define a line without using the word point or the word line in it. And since points are not definable, you can't define a line properly. So he said you cannot define lines. And then he came to the word plane, which is a flat surface, and not an airplane, but flat surface is a plane. And he wanted to define plane, and he again recognized the need to say the word plane in the definition of plane, as well as lines and points got jammed in there. And he said, nope, I'm not going to define those either. So these are the three undefined terms in geometry. So it is important, and you want to note that. You definitely want to note that points, lines, and planes are undefined. They are undefined in geometry, but we can still understand them, and we should. So let's go ahead and see if we can understand a point precisely. Point is a position in space. It could be on a plane. It could be out in space, though. It doesn't have to be on this whiteboard, which is a plane. But I put it on the whiteboard because it's easy to see. That's another thing. A point isn't something that you would actually be able to see. A point has zero area. It has zero thickness. A point is so thin you wouldn't actually be able to see it. But we put a dot on the board to identify where that point is, but we shouldn't think, oh, well, that point is ½ inch thick, because Mr. Myers drew a ½ inch thick point. And that's just a position, and this is just showing us where it is, but we actually wouldn't be able to see it. It'd be so small. A line is the next thing. A line is a collection of points. So a collection of points. So if I were to just do a bunch of points off of this blue point here, or a bunch of red points, lines are just a collection of points. So in that sense, the thickness of this line, its thickness here, is actually zero thick. Its thickness has got a zero thickness, which means we really wouldn't be able to see this line either. It'd be so thin we wouldn't be able to see it. But to represent it, we need to draw this thicker line that shows, that's representing the line. But the line is actually 0 inches thick. It's zero thickness. Okay? But it's just a collection of points. And it's always straight. We should identify that. It doesn't curve. This is not what we would call a curved line. It's just a curve. It's not got anything to do with a line. A line is straight. Curves are curved. So a line is always straight. And lines always go on forever in both directions, and that's why we must give it little arrows. These arrows identify that it goes on forever, both to the left and to the right in this case. They are going on forever. So a line goes on forever. And it's just a collection of points. The next is a plane. A plane is a little bit more complicated, but we have them all around us. TV screens are planes. This whiteboard itself is a plane. So I can draw on this plane, I could draw a plane. Now, is the plane this size? Absolutely not. In fact, this plane goes on forever in all directions. It goes that way forever. And it goes that way forever. And that way. And that way. And it's not square. It's just infinite. It goes on forever. Just like lines go on forever, planes are really a collection of lines. So if I were to just draw a line on, and then a line right next to it, and a line right next to it, and a line right next to it, forever, I get myself a plane. And remember, each of those lines is going on forever in both directions. Well, I could draw the line, I could stack them both ways, and they're going on forever. And the lines are stacked forever. So a plane is a collection of lines, really. So you can think of it that way. So I do like to think of it as points are these infinitely small positions in space, and a line is just a collection of them. And a plane is just a collection of those. So we've got some other terms here. We've got triangles, angles, rays, and segments. So let's go ahead and look at a segment first. I think segments are fun to look at. I'm going to get rid of our plane here. Segments are definable. We can define a segment. A segment is a collection of points, but it would be a collection of points that terminate or end, have an end to them. So if I had a point here and a point here, and I said those were my end points, and I put a line segment, a section of a line, in between them, that's a segment. A segment is like a line, only a line goes on forever in both directions, whereas a segment ends or terminates at 2 points, 2 positions. So there are 2 terminal points to a segment. The next is a ray. So we've talked about segments here. Let's go ahead and talk about a ray. A ray is kind of in between these two. It has a starting point. So a starting point. And we can put that starting point anywhere on the board. It would be the point at which it starts. And a ray goes on forever in one direction. It's only got one direction. In that one direction. And there you go. Most of the time we'll have positions identified on there. So in this case, this is my starting point and it's going this direction. So how can we talk about it? Well, we can talk about it in terms of letters. So we could say this is point A and this is point B. And this is a ray that starts at point A towards point B and then on forever. Okay? So that's a ray. And then the last is angles and triangles. So let's go ahead and give some letters to some of these other things. So let's do C and D for them. And then let's give this line E and F. So let's say you wanted to write about point E. You'd say point E, or you would just say E. That's this point here, point E. If we want to talk about line containing E and F, or we could call it line EF, we could write out the word line, but we don't have to. We just say EF, and we put a line above it. Notice it's got arrows on both sides that identifies it as a line, and this is line EF. Okay? Let's say we want to talk about segment that contains C and D as our endpoints. Then we would call this segment CD. And notice we put this dash above it. This is really a line segment. It's a segment. It doesn't have arrows on the ends. It's a segment. And let's say we want to talk about the ray. Starts at A, goes through B. We've got ourselves A, B, and it's a ray. Notice it's only got one arrow. Then you say, wait a second, could I have written some of these a little differently? And the answer is absolutely. So I could write FE as my line. Line FE. Line FE is line EF. How about segment CD? Could I write that as segment DC? Absolutely. Segment CD is segment DC. They are the same segment. There's no difference. Now can I write ray BA? And the answer is kind of. You can't have the arrow going to the right because the arrow doesn't go on forever after A. It's going forever after B. But we could write the arrow going to the left instead. So we've got ray AB. This is kind of taboo, so we don't generally do it, but it's absolutely allowed. You could write BA and then have the arrow going to the left, but it's kind of weird. I would stick with this one. It is acceptable. So I am letting you know that mathematicians do occasionally write it that way. I've seen it myself. So it is acceptable, but it is kind of weird. So you can do that. All right. The last thing, so we've talked about rays and segments. We've talked about how we could write them down. The next we should talk about are angles. So let's go ahead and talk about angles. I'm going to switch up our color here. We're talking about angles. So angles kind of take pieces of what we've already talked about here with points and lines and segments and rays, and we put them together. It's basically like, let's say we had a ray, okay, it started here, and then we had a second ray that went through that same point as its starting point. So both rays have the same exact starting point. And let's go ahead and identify some letters here. So we've got letter G, H, and J. We've got these two rays, ray GJ and ray GH. And from here we can see that they form a vertex. G is the vertex. It's where the two rays meet. The two rays meet at what's called the vertex. So the vertex is G. And it forms an angle. This is an angle here. We don't know what that angle is. It could be 50 degrees, 70 degrees, somewhere in there probably. And we can identify this angle as angle JGH. Angle JGH. Another way of writing it, this is a way to write this angle here, JGH. Another way of writing this angle is to do a little arc through the angle, angle JGH. Now you might say, wait a second, is there any other ways you could write this? And the answer is absolutely. So we can write it a couple more ways. We could start with H, and then go to G, and then to J. H to G to J. And that would also be an angle. Angle HGJ. And that's an angle. The last way we can do it is, of course, to put the little arc mark there, which is totally preference. So if you prefer to have the angle mark, put it there. I usually do, but you don't have to. You can do an angle like that. So angle JGH. And you say, wait a second, I see another way. In fact, you might see a couple more ways. You could write GJH. You can't though. The reason is we're not going from G to J to H. That's not our angle. If you wrote GJH, you'd be going this way, and you'd be talking about that angle there, and that's no good. So we cannot write GJH. You say, well, could we write GHJ? Same problem. GHJ, if you wrote angle GHJ, you'd be talking about this angle here, going from G to H to J. And we can't do that either, because that's not the angle we're talking about. We are only talking, at this point, with this picture, this diagram here is showing us just that angle, which could be represented as JGH or HGJ. So those are the only two ways you can write it. So these are your options. You say, wait a second. The vertex is where they meet. So this is angle G. So couldn't we just say angle G? And the answer is absolutely. So that's another way of writing this, is angle G. So we've got angle G, or angle JGH, or angle HGJ. So those are our options. So you can just use the letter that the two lines intersect at, or rays in this case. The two rays are intersecting at point G, so it is angle G. So that is absolutely correct to write as well. You say, is there any time where I have to write this, I cannot write angle G? And the answer is yes, there are times when you have to write all three letters and you can't just write one. So let's say you had another ray coming out of angle G, out of point G. And we'll give that letter K. Let's say we still wanted to talk about angle JGH. Well, JGH is very clear. It's telling us which angle we're looking at. We're not looking at JGK. We're looking at JGH. This one, again, same thing. HGJ. We're looking at the bigger angle. We're not looking at HGK. We're looking at HGJ. So then you say, okay, what about angle G? Does that represent angle JGH? And the answer is no. Once you say angle G in this picture, we say, which angle G? Because there's three of them, isn't there? There's that angle, and then there's the big angle. There's three angles there. So angle G would not be appropriate if there was a third ray coming out of that same vertex. So we can use this, but only under special circumstances. You can always use these. So that's why I would prefer you to use the three-letter combination as often as possible, because it keeps you from getting answers wrong when you say just angle G, when you've got three rays coming out of it. So just keep that in mind. Something that I think I've seen a lot of, and I like to try to point out student mistakes that happen a lot, so that I can help you to not make those same mistakes. So one thing that I've noticed is that a lot of times students try to only give me 2 letters for an angle, or they'll give me 3 letters for a line. These are incorrect. Notice in the angles, we always have either 3 letters or 1. That's it. And if you forget about the 1 and just say, you know what, I'm always going to do 3 letters for my angles, that's great. 3 letters for an angle, 2 letters for a line, 2 letters for a segment, 2 letters for a ray, 1 letter for a point. You can have 1 letter for an angle, but you better have that angle symbol in front of it. No angle symbol in front of it just means a point. So if you want to talk about a point, you're just going to put the letter down. Lines, segments, and rays, 2 letters. It's a must. You have to have 2 letters. And for angles, 3, except for in special circumstances you can have just 1, but you must have the angle symbol in front of it. So hopefully that all makes sense, and we can make sure we do this right every time. 3 letters for an angle, 2 letters for lines, segments, and rays. Okay, the last thing we've got are triangles, so we're going to look at a triangle. You can kind of see that there was a triangle starting to form here with JGH. So we're going to get rid of it and we're going to redraw it. I think we can get rid of this as well. So let's go ahead and look at a triangle. So we're going to do same letters, J, G, and H, because why not? This isn't a triangle, is it? This is just an angle. But now it's a triangle. Tri meaning three, angles. Triangle has three angles. And you can see the three angles, right? There's angle G, which we talked about. There's angle H, and there's angle J. Of course, we could write it angle JGH, which we would be talking about this angle on the left, or GHJ, we'd be talking about the one on the right, or GJH, we'd be talking about the angle on the top. So we've got three angles there. A triangle is formed with three segments. Notice they're segments. They don't have arrows going off of them. And even if they did, we'd still be able to talk about the terminal segment JH, even though it continues on in the picture. Segment JH still exists in the picture, and it terminates. So even if we had arrows going off of this, going up and down, we could still talk about segment JH being a segment of the line. It's a line segment. But we don't have arrows. We don't need them. We can get rid of them. So we've got three segments, and this is called a closed shape. It's a closed shape because there's no way to get in. If you were walking along and you found this barrier, and say these were 20-foot walls, there would be no way to get in. Whereas an angle is an open shape. You can walk in. 20-foot wall, making the triangle. You could walk in to the triangle because it's not closed on the third side. You say, well, what if it was almost closed? But not quite. There's still a gap there. You could get in. It's not a closed shape. So a closed shape, there's no way to get in from the outside without going through the barrier. Okay? So it's a closed shape. What else can we say about triangles? I think we've covered the angles pretty well. There's points, point J, G, and H. Those are the vertices of the triangle. There's three vertexes to this triangle. Vertex J, vertex G, and vertex H, which means that the angles meet, the two segments meet. Segment GH and segment GJ meet at point G, which is called a vertex. So we have three vertexes on a triangle, always. And triangles have some special properties, such as if you were to measure the three angles. If we were to measure these three angles and add them up, the angle G plus, let's write measure. The measure of angle G, that's how it's read, plus the measure of angle H, plus the measure of angle J is equal to 180 degrees. And that's probably one of the most important things to remember about triangles. Mathematically, we use that as a fact a lot, and it helps us to prove other things. And that's called the triangle sum theorem. The triangle sum meaning S-U-M, adding together. Sum meaning adding. Triangle sum theorem, if you add up all the angles of a triangle, they always add up to 180 degrees. And that is Euclidean geometry. So there's definitely a difference between all of these, but our main focus is what a construction is. So let's go ahead and start off real quick with what a drawing and a sketch is. Most definitions of a drawing is something that is done freehand with no extra assistance. You're just sketching it out, you're drawing it up. So you say, wait, what's the difference between drawing and sketching? Well, sketching is a quick, quick freehand drawing. Although if you look at definitions of more current definition of drawing and sketching, because of the increased use of computers in aiding art, if you're drawing freehand on a computer, that's a sketch. So also a computer drawing. And you say, well, a computer drawing isn't always freehand. Well, then it might not be considered a sketch anymore. If you're using a program to correct your lines or make them specific angles, it may not be considered a sketch anymore technically. So a sketch is usually considered freehand, so is a drawing. Drawings are usually more hand done with pencil or paint or whatever. I mean, a painting could be considered a drawing in essence. Whereas a sketch is doing it real quick. So you're trying to draw it real quick, but it also can be computer aided drawings. So computer aided drawings have been coined sketches. So we do want to kind of keep that in mind, but really our focus is constructions. So constructions, we are using a compass and a straight edge. So what is a compass? Well, you've probably seen them. They're usually a V-shaped, and they open. They have a swivel piece here that allows you to open and close them. Here is an attachment piece here for you to insert your pencil. And over here is just a pointy, sharp thing. It's just a point. And the point of the compass is what you set down onto the paper, and then you swivel the pencil around to form a nice circle. So you can use compasses for constructions, and they form circles. And they usually have a pencil end and a point, and they open up. And you can actually open it up, and they usually tell you degrees here. Around the circle, there's usually degrees. So it identifies that you're at a 45-degree angle and so on. So a lot of them do that. So you can kind of identify what angle you're at on your compass. And the last thing is a straight edge. You know them as rulers. It's just a straight piece of wood that you can draw straight lines with. Any more rulers have all kinds of markings on them telling you how many inches, how many quarter inches, how many eighth of an inch, 16th, even some more precise rulers go up to 32nd of an inch. So they get you really precise lengths. A straight edge is something that does not measure length at all. It is only meant to measure, to draw, not to measure, but to draw straight lines. So in a construction, you should only be able to draw circles and straight lines, and never be able to measure their lengths during the construction. The construction is not based on measuring lengths or anything like that. So constructions are pretty rigid. They don't have a lot of options. There's no opportunity to do any freehand at all. It must be done with compass and a straight edge. There are other compasses out there, ones that don't look like this at all. They look more like a ruler, and what they have inside of them They're pretty neat, actually. What they have inside of them is a hole here, big enough for you to put either a pencil down in there, or you just press with your thumb there and hold it still. And then what they'll do is they'll have another set of holes, usually like that. So you can put your pencil in here, hold down with your thumb there, and spin the whole thing around, and it would get you a circle. Or, and usually most of these have that, is a circle here with a place for you to press down with your thumb, and then a bunch of holes like that. So you press down with your thumb, insert your pencil into the hole, and the whole thing spins. This thing. So you can get really tiny circles, or you press here, put your pencil in there, and spin and get big circles. So, and these compasses are much easier to work with, and they're more hardy. They don't break as easily, and they're a little bit easier to use. They're a little bit newer. This is the old traditional compass. This is a newer, kind of ruler-y looking compass. You can also use them as a straight edge. So, and they usually have markings for measurements, so you can get pretty accurate with one of these, and you don't need a ruler and a compass. Your compass is your ruler, so that's pretty nice.